Okay, so this is when this is if this is row 1, this one is row 2, this one is row 3. You can see that let's swap row 1 and row 3, or let's interchange row 1 and row 3. So this 3111 will place the row 3, the 431, and the 431 will come up. So that's what they've done here. And you see, so the row interchange is the simplest form of what the Gauss-Jordan operations. We are saying it's elementary row operation, arrow. So it's only done on the rows, and it's done at a time, row by row. You cannot perform one operations on 2 rows at a time. No, you perform one operations at one operation at 1 row at a time. Do you get it? Good. So row interchanging meaning you just interchange your positions. So this one, they say if you interchange rows 1 and 3, you get this. So the row 3 here becomes row 1 here, and the row 1 here becomes row 3 here. Row 2 remain what? Constant. All right. So I hope this one is okay. Now let's move on to solve examples using the Gauss-Jordan method. How do we get an identity matrix of a normal matrix? You get it? So I've taught you how to write an expression like this in what? An equational form, like in a matrix form, sorry. So if you are having something like this, you just write the coefficients in one matrix, the decision variables as x in one matrix, and the resources. So when you take the A here like this, the coefficient 3, 1, 4, you get it. Then the 1, 1, 3, then 1, 1, 1. That's what they've done here. After that, you put all the decision variables. Now here you are having 3 decision variables, unknown variables, S1, S2, S3. You place that one too in what? Another matrix. You multiply it with the coefficient because it was multiplying the coefficient. The coefficient was multiplying the decision variables. After that, you equate it because here it was equal to their resources. So equal to 20, equal to 40, equal to 10. So that one too, you equate it to what? Their resources. So this is how you write mathematical expression in a matrix form. Now, after writing the equation in a matrix form, they are saying that if the matrix operation above can be transformed into identity matrix. Now, I taught you what identity matrix is. I said they are made up of what? Ones and zeros, and the ones are in diagonal form. You get behind the diagonal, and the rest of the elements are zeros. So, and it's also what? A square matrix, either 2 by 2, 3 by 3, or 4 by 4, 5 by 5. Yes, it's only square matrix. Now we are saying the special property taught us that when you multiply a normal matrix, that is I, identity matrix I by a normal matrix, let's say X, the answer you get is the normal matrix, the X you get. It's like multiplying any number by 1, you get that number. So 5 times 1, 5, 7 times 1, 7, 1,000 times 1, 1. So it means the identity matrix is like 1 multiplying what? Ordinary number in multiplication. The same thing applies here. When identity matrix, so this one is identity matrix because it's a square matrix, the ones are in diagonal and the rest of the elements are at zeros. So this one is a perfect example of square matrix. So this one, when it, let's name this matrix as I, this one as X. So when it multiplies this, it means this one won't count. You still get the answer as S1, S2, S3. Then you equate to C1, C2, C3, and that one becomes your answer. All what they are saying is that now they are telling us that we can use identity matrix to solve for unknown variables. So they are saying this element, this matrix here, you must perform the arrow or the Gauss-Jordan method, the arrow operations on this matrix. And this matrix A here will turn to what? Matrix I here. And before it turns to I, this matrix B, the resources, the 20, 40, 60, will change to something else. And it will change to what? The C1, C2, C3, and so on. So when you multiply the I here by the matrix X here, you are going to get what? Matrix X is equal to what? C. So your final answer will be something like S1, S2, S3. And the C1, C2, C3 will be the values of X1, S2, S3 that you are solving for. That's why I told you the other time you can use a matrix to solve for known variables. You get it. So any question before we move on to take a typical example and solve? Any question? I guess you understand. Okay. Now we are saying the first thing you have to do before you perform the error operations is augment. You augment the what? Matrix. Now what do you mean by augmentation? Now by augmentation, let me take this example. So we are solving for the values of x1, s2, s3. We don't know them. So this one is fixed. You get it? So we just eliminate it and you bring the 311, 111, and 431. Then you will bring a line here. You just attach your resources to the matrix here. So 20, 40, 10. So when you augment it like this, every operations you perform on the first row here must extend to where? The resources first row. Any operations you perform on the third row here must extend to what? The third row for the resources matrix. But first it was equal sign, but augmentation, you just ignore this, the x1, s2, s3. Then you attach or you bring it closer to what? The matrix A here. You just separate it with a thin line like this. Then every operation you perform here must extend to what? The resources that you attached to the matrix A. So let's take an example here. Okay. So they've done augmentation. You see, they ignore the S1, S2, S3. So they are saying if you perform this operation, so 3 times row 2 plus row 1. So this is our row 1, row 2, row 3. Now let's perform this operation here. Let's take the first row and see something. 3 times row 2. So 3 here, row 2 is what? 1. So 3 times 1 plus row 1 is what? 3. You get what? You get 6, right? So that's why you are seeing 6 here. Let's take this one. 3 times 1 plus row 1. This is the row 1. We are talking about the second column, row 1 here. So that one too is 1. Your answer is what? 4. You perform the same for the third element on the what? Third column is what? The same 4. Now, I said when you augment, every operation you perform here, you must extend to what? Another matrix you brought it closer to the normal matrix you were having. So you have to perform the operations on the 22. So it will be 3 times row 2. Row 2 is 40, right? Plus row 1. What do you have there? Row 1 is 20. Now 3 by 40, you get 120 plus the 20 we have here. We are having what? 140, and the 140 is here. And now, when you pick operation like this, this formula like this, you have to decide on which row you are going to perform that operation. Which row are you going to perform that operation on? So this one, we perform this operation here on the first row of this matrix. You get it? Because when you look through the answer here, the row 2 and row 3 were constant. It didn't change. It was fixed. But the changes were made to only row 1. Okay, so the same thing they can tell us after augmentation. They can tell us to interchange row 1 plus row 2. Yeah, so we are going to use this new augmented matrix. So row 1 plus row 2. So this one is simple, but they are saying we should perform the operations on what? Row 2. So the row 1 will remain constant. So 644 will come 644. Then 140 will be here. Then we perform the operation on row 2. So row 2, they are saying row 1 plus row 2. 1 plus 6. 6 plus 1 will give us 7. 4 plus 1 will give us 5. 4 plus 1 will give us the same 5. Then 140 plus 40 to give us what? 180. Then the row 3 will remain constant. Everything will not change. You get it? So I said the arrow or the Gauss-Jordan method is saying that when you pick an operation, just perform it on one row at a time. You don't perform one operation on 2 rows at a time. Even if you are combining 2 rows, you cannot do it on the same rows. You must do it on only 1 row. And now these are the rules. You can add 2 rows. You can subtract a row from another row, but you cannot multiply a row by another row. You cannot divide a row by another row. You can only multiply a row by a non-zero scalar, like a number which is not 0. It's either negative or positive. Yes. And you can also divide by what? A non-zero scalar. I repeat, you can add 2 matrices. You can subtract a matrix from you can add 2 or more rows. 2 rows. You can subtract a row from another row. So let's say row 1 minus row 2, row 2 minus row 3. That one is acceptable. But you cannot multiply 2 rows. Let's say row 2 times row 3. No. But you can only multiply a row by non-zero scalar. When you talk about non-zero scalar, it means any number which is not 0. It can be negative or positive. And you can also divide by a non-zero scalar. But you cannot add and divide 2 rows. You cannot multiply 2 rows 2. All right. So any question before we move on? And the third example here was saying, this is our new augmented matrix. Let's interchange what? Row 1 and row 3. So everything on the row 1 here will be row 3 in our answer. Then everything on the row 3 here will be our row 1 in our answer. Right, so we just interchange the row. Now, just remember that I'm saying when you augment, the moment you bring a line in between 2 matrices and you attach that resources to the normal matrix, every operation you perform on this row must extend to the new matrix you brought, you attached with the normal matrix you were having. All right. So I hope everyone gets this and we can continue. Any question before I move on? Or we are going to take a typical example and solve it. Any question? Hey. All right. Any question? Okay. So let's move on. To obtain the solution for the system of linear equations, continue to perform arrows till Ax is equal to B is transformed to the form Ix is equal to K. That is until the matrix A is transformed into an identity matrix. Now I told you what an identity matrix is. So they are saying this is Ax. Now they are saying Ax. So Ax means A is multiplying X. So it's true that the matrix A here is multiplying matrix X. It's equal to what? B. They are saying we should perform the arrow operation that like multiplying a row by a non-zero scalar, dividing a row by a non-zero scalar, adding two rows, subtracting from a row from another row. You must perform those operations until the ASB here is transformed to IS is equal to K. Now, what do you mean by IS is equal to K? Now, this one is B. And I said, the moment you start augmentation, you move to make the X. So your final answer, you work the arrow operations or the Gauss-Jordan method, the arrow operations, elementary row operations. You perform it on this matrix till you get what? Identity matrix 3 by 3. So that will be 1 0 0 0 0 1 0 8. Sorry. 0 1 0, then 0 0 1 here. So you must perform the arrow operations on this. Till you get this, so the 3 here, you perform some operations. You yourself have to think and give yourself your own formula, so that you change this 3 here to 1. This 1 here to 0, you transform the 1 here to what? 0 2. And every function or formula you choose for 3 must be applied to what? 1, 1, and the 40 as well. So you are going to change the matrix here, matrix A, to identity matrix I. And you bring what? You multiply it with your matrix X you were having. So X1, X2, and what? S3. Then when you finish, you equate it to what? Now this B will change. But remember, I told you when you eliminate this and you augment the matrix A and B, every operation you perform here must extend towards this row. So by performing the operations to get the identity matrix, by the time you get the identity matrix to be this, your 40, 30, 60 will not remain the same. It will change. And they are saying it will change towards K. So the B here will change towards K. So let's take it as we don't know the number we get. So K1, K2, and what? K3. Now it is identity matrix multiplying what? The X here is equal to K. Now in the special properties we learned that identity matrix times normal matrix gives us a normal matrix itself. It's like 1 multiplying any other number. 1 multiplied by -10 is -10. You get it? So identity matrix multiplying the matrix X here, you are going to get X, your final answer as S1, S2, and S3. Okay? And you equate it to what? The K that you get, the B will transform to K. So K1, K2, and what? K3. And that one will be our answer for the decision variables S1, S2, S3. That's why I say we can use matrix to solve for the value of what? Unknown variables or our decision variables. Now, any answer before we take any question before we take start question here and solve. Okay. Any question at all? Make the discussion interactive. You get it? It seems you are having lectures, but it's a discussion. So please, guys, talk for me. All right. We are going to pick a question. We are having this expression here, and we know how to change it to a matrix form. So we just pick their coefficients, you put them in one matrix. So this one will be 3, 1, 311, 111, 431. Then you put the decision variables S1, S2, S3 in another matrix called X. You equate it to what? The matrix B, that's the resources. Then you start performing your arrow operation. All right, so the meeting will end in 3 minutes time. I don't want to start the workings. By the time it ends, I have to start again and everything will be lost. So please, I'm just ending the meeting. Just rejoin it again using the same link. All right, so that we will continue right away. So join with the same link. I'm ending this one. All right. So this one, you just rewrite it in. So the first matrix will be for what? The coefficient. The first matrix will be for the coefficient. Now, what are the coefficients? What are the coefficients? Mention them for me. What are the coefficients? So this one is matrix A. Hey, I'm asking you guys a question.
3, 1, 1.
3, 1, 1.
1, 1, 1. 4, 3, 1.
Okay, that's the first matrix will be for the coefficient. Now, the second matrix will be for the what? Decision variables. It was x1, x2, and what? X3. All right. Then we have the last one to be our resources. So it was 40, 30, and what? 50. Now, we want to change this matrix here, matrix A here, to what? Identity matrix. And identity matrix, our final answer must be this. So this is where you think critically. Okay, so how are you going to change this 311, 1111, 431 to what? 100, 10, 010, 001. How are you going to change that? How are you going to change it? We change that by what? Following Gauss-Jordan method, arrow, elementary row operation. Now the first one is saying we must augment. Now by augmentation, this one, matrix X here is fixed. We don't know any value for it. We are now searching for the value. So we just eliminate it. You get it, you just take it off and augment the A and what? The matrix B here. So augmentation, by augmentation, we have 3, 1, 1, 1, 1, 1, and 4, 3, 1. You bring a line here, then you attach the resources or matrix B. 40, 30, 60. Now then you start with your what? Operations or your formulas. Now, bear in mind you, every operation you perform on the first row here, because you've augmented the two matrices A and B, you must extend that operations to what? The row of that matrix B. So we have matrix B and matrix what? A. So every operation you perform on matrix A, extend it to what? Matrix B. Simple like that. All right, so we want our matrix here to transform to be like this. Do you get it? So the first operation will be what? I'll represent R by row. Let's subtract row 2 from row 1. So row 1 minus what? Row 2. Row 1 minus row 2. And we are performing the operation on the first row. So this is row 1, row 2, and what? Row 3. We are performing the operations on the first row. So the row 1 minus row 2, we have Row 1 minus row 2, this is row 1. So 3 minus row 2, you take the same element and add it. We have what? 1 here. Are you following? Or are you lost? Hello?
We are following. We are following.
Okay, so 3 minus 1, you have what? 2. And mind you, I said you have to perform the operation here, the formula that you have chosen. You must apply it on only one row at a time. So we are applying it on the first row. So with the 2 rows left, the second row and the third row, nothing will change. So that one is 1, 1, 1, 4, 3, 1. Okay. Then the rows here, nothing will change. The row 2, so 30, 60 here. So row 1 minus row 2, we perform the first one. So 1 minus 1, we have 0. 1 minus 1, we have 0. 40 minus 30, we have what? 10. 40 minus 30, we have 10. Okay, any question in the first one before I move on?
No question.
Okay, so we are moving to the second one. The second one, we want these two to be like 1, 0, 0. So which operation can we perform here?
We can divide row 1 by 2.
Okay, so let's divide row 1 by 2. So that will be row 1 divided by 2. Mind you, I told you, you cannot divide a row by another row, but you can divide a row by what? A non-zero scalar. Non-zero scalar means number which is not 0. So it can be negative or positive. So let's do that. So we are performing this on row 1. So row 2 and 3, nothing will change. So we have 1, 1, 1, 4, 3, 1. Augmentation line will come. So 30 here, 60. Now when you divide 2 by 1, you get what? 2 by 2, you get 1. You get it. Row 1, 0 divided by 2. 0 divided by 2. When you point your calculator, it will give you 0. But if it was 2 over 0, it won't come. But 0 divided by 2, it will come. So the second one too is 0. Now, mind you, I told you every operation you perform on this row must extend to where the 10 is. So 10 divided by 2 will give us what? 5. Okay, so we are moving forward. So the next row, we've done with what? Row 1, because we have gotten the 1, we have gotten the 0, we have gotten what? The 0 here. 1, 0, 0. So we want the rest to look like 0, 1, 0, 0, 0, 1. Okay, so the next operation, I will suggest that let's subtract row 1 from row 2. So row 2 minus what? Row 1. Row 2 minus row 1. We are performing this operation on what? Row 2. We are performing this operation on row 2. So row 1 and row 3, nothing will change. Row 1 and row 3, nothing will change. So just name them 1, 0, 0, 10. Then row 3, nothing will change here. 4, 3, 1, 60. So row 2 minus row 1, you take row 2 first. Row 2, this is 1 minus row 1, this is 1. We are getting what? 0. Row 1 and row 2 is what? 1 minus 0. We are getting what? 0. 1. 1 minus 0. Your answer is 1. But if it was 0 minus 1, your answer would be what? Negative 1. But this one, 1 minus 0, so your answer is 1. Now, the same 1 minus 0, 1. Now 30 minus 5, you are getting what? 25. Okay. We are moving on. So let's see, 1, 2. Okay. Let's move on to our fourth step. First step, we are saying root 3 minus what? 4 multiplying row 1. Mind you, I said you can perform 3 operations at a time, because when you look at this, it is row 1 is subtracting from 1. You are subtracting row 1 from row 3, but you are multiplying 4 by row 1 before you subtract it from row 3. You get it? Now we are performing these operations on row 3. This one you are performing on row 3. So row 1 and row 2, nothing will change. Row 1 and row 2, nothing will change. It will be 0, 1, 1, 1, 0, 0, 0, 1, 1. Then you leave the third row, because the third row is where we are going to perform the operation. Then we have what? 10, 25. This is 0, right? This one too is 60, 0. Okay. So this one you have to, so row 3, you use this previous matrix to do it. So row 3, the first element here was 4. So row 3, 4 minus what? The formula is 4 again, multiplying row 1. Row 1 here, so 4, we took it from here. So 1, the corresponding number is what? 1. So you multiply it by 1. Now, what will be the answer?
0.
0. So here will be what? 0. Let's take the same formula here again. Use the element on the second one. So row 3 is 3 minus 4 times what? 0 top. You get it? What will be the answer?
Minus 1.
Come again. Come again. Four minus 4 times 0 is 0. So 3 minus 0, you are getting 3. All right. So don't confuse yourself, please. Whenever hard, then you use calculator. Okay. So we are left with what? The third element here. So the third one, root 3, the formula is saying root 3 minus 4 times root 1. So root 3, the element there is what? 1 minus 4 times root 1. Root 1, what is the element there? 0. So this one too is 1 minus what? 0. You get 1. So here will become 1 for you. The same function, let's use it to transform the system here. So root 3, this element. So mind you, I told you that every operation you perform here must extend to the matrix behind the thin line you drew. Okay. So the row 3, we are having 60 there because it is found on the third row, minus 4 times row 1. Row 1, what is there? 10. All right. So it will be 60 minus what? 40. We are getting what? 20. So here it will become 20. Okay. So this one, you have to think and formulate your own what? Function or something like that, yes. If you use the SMART method, you shorten your what? Steps. And so there you can do it till.
The row 1, is it 5 or 10?
Eh?
I thought row 1. Is it 5 or 10?
Row 1.
We had 5 here when we
Oh,
divide
sorry.
10 by 2.
Okay. Thank you. So this was from rule 5. This is rule 5. The only place you change is this place, right? 1325. Okay, so this is the only place. So let's take it again. 60 minus 4 times 5. So 60 minus what? 20. We are getting what? 40. Let's see, the 10 here is 5. So you see, I was writing this one. If you don't concentrate, okay. Yeah, thanks for the correction. All right, so let's move on. So we are performing the arrow something on this matrix before till we get to what? This identity matrix here. So now we are getting to our 5th step. So the 5th step, we are saying that root 3 minus what? 3 multiplying root 2. And we are performing that on what? Root 3 again. So when you take root 3 minus 3 multiplying root 2, we are doing it on what? Root 3. So the first row and second row won't change. So 1 0 0 0 1 1. You bring your 10 line. Then here to be 5 25. So just pick root 3. Root 3, the element here is 0 minus 3 multiplying row 1. What's the element here? So what do you think the answer will be?
0.
What do you think the answer will be? Hold on, I'm coming. So this one is 0 minus 3 because we are dealing with the root 2 and root 3. So the root 3 is 0 minus 3 multiplying root 2. The root 2, the element there was 0. So your final answer must give you 0. That's why we've written here. Now use the same format here, root 3. Yes, it was 3 minus what? Root 3, 3 times root 2. Root 2, what is there? The element is 1. So this one gives us, this one also gives us what? 0. But 3 by 3, 3 minus 3 by 1, 3. So 3 minus 3 will give us 0. So this one will be 0. You get it. Then you also use the same function here, or the same formula. So the root 3, the third one, it is 1 minus 3 multiplying root 2. Root 2, what is there? Positive 1. So this one needs to be 1 minus 3. We are getting what? Negative 2. So here will be negative 2. All right. Then we take the 40 here. 40 is root 3 minus 3 multiplying root 2. Root 2, what is there? 25. We get it. So 40 minus 3 by 25. We are getting what? 75, right? So So 40 minus 75, we get negative 35. So the number here should be negative 35. You see that the resources, which was B, is gradually changing, and it will become the K we were talking about. All right. So as the A here is changing to I, the B here is also changing to K. Okay, so let's move on. So now that we've gotten this, we can do something on equation 3, row 3, because we want it to look like 1 0 0 0 1 here 0, then 0 0 1. Now we want this matrix here to look like this. We can still perform something on row 3. Let's finish that. What do you think? What do you think the operation would be? We can do something to row 3. So we have 0 here.
Should I talk?
Yes, stop, please.
Okay, let's divide row 3 by -2.
Yes, row 3 by -2 do. So row 3 by what? -2. So that one will be what? So the row 1 and 2 will be faced. So nothing will change there. So this one is 5, 25. All right. So this one is what? 0, 1, 1. This one is 0. 0 divided by -2 is 0. 0 here. Now -2 divided by -2, it will cancel out. You get +1. Now here to -35 divided by -2, you get what? +17.5. The negative will cancel the negative, and 35 divided by 2 is 17.5. Now you see that we've gotten the 1, we've gotten the 0 here, we've gotten the 0 here, we've gotten the 0, we've gotten the 0, we've gotten the 0, we've gotten the 1. So now it's left with row 2. Here is 1, we've gotten that one. So here we want it to be 0, but here it is 1. So what do you think the operation will be? This one, the fella. Oh, back. Okay, what do you think the operation will be? Here is row 1, here is row 2, here is what? Row 3. So just take it this way and every operation. Okay, but for thought. Z.
Row 2 minus row 3.
Okay. So therefore is saying row 2 minus row 3. All right. So row 2 minus what? Row 3. All right. So the row 1, nothing will change. So but where are we performing that? Are we performing that on row 2 or row 3?
Row 2.
Row 2, yes, because the 1 and row 3, there is nothing wrong with that. So 0, 0, 1, then 17.5. All right, 5. Okay, so row 2. So when you take row 2 first, so row 2 here is 0, 0. We are getting 0. Now, row 2 first, it is 1 minus what? Row 3, 0. We are getting +1. And this one, row 2 is 1 minus what? Row 3, 1. We are getting what? 0. Now here, 25 minus 17.5. What do you think the answer will be? A minus. And 25 minus 17.5.
7.5.
Okay, 7.5. Now we are not done. You see, we've gotten our identity matrix here. But remember, we eliminated a particular matrix. So that matrix was X. So we bring that one in position, we rewrite it again. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Then you bring your matrix here, it was multiplying X, X1, S2, and what? S3. Then you equate it to what? The B, which was 40, 30, 60, has now changed what? By 17 and 17.5. So 5, 7.5, then 17.5. So this one has one matrix I, X, then let's take this one as K. So now why did I tell you about like matrix, the identity matrix, the special property of identity matrix? So now it's like I is multiplying X is equal to K. What do you think the answer would be? Fast. How do you think the answer would be?
X.
X, because when you multiply identity matrix with a normal matrix, we get the same normal matrix. So your answer would be X is equal to K. You get it? You get X is equal to K. Now the X is equal to K, you rewrite it with their matrix. So X is equal to, so the X was what? X1, X2, and what? S3 equal to 5, 17.5, 7.5 rather, sorry. 7.5, then what? 17.5. So our final answer is this. X is equal to 5, S2 is equal to 7.5, S3 is equal to 17.5. So that's why I told you you can use matrices to solve for the values of decision variables. Now, with this whole something we went through, we can use Microsoft Excel to do it within seconds. And that one, I'll teach you in our next meeting. Yes. So we are going to take another question under this type of matrix, that is using identity matrix to find the unknown variable or to find the decision variables. After that, next meeting, I'll teach you how to use Microsoft Excel to solve for these unknown values. Then we move on to finding the inverse of a matrix. Now, finding the inverse of a matrix is similar to this type of identity matrix that we are doing. But that one to, like, you add something small to it. You are going to solve for the identity matrix, but that one is a bit different from this one. Okay. So any question before we take another question to solve? Anyone having a question here? If anyone is having a question here, I beg, please bring it up. Hello.
No question.
Anyone having a question? Okay. So are you trying to tell me you've all understood it, right? Okay. Bafo is saying no. So is it no question for everyone or just Bafo? No question for everyone. All right. If no question, then the meeting will end in 5 minutes time. Just rejoin it. So you are having a mathematical expressions like this. Equation 1, equation 2, equation 3. How are you going to write it in your heart? Matrix formula. First of all, I said put the coefficient in one matrix. This is variables in one matrix. You equate it to the resources. So the coefficient we have is what? 20 here, 20x1. The x1 should be here. So 21, 0. Then 15, 2, 0. So 15, 2, 0. The next one is what? 10. The S3 is 10, 1, 1. Then it is multiplying the x1, s2, and what? S3. Equate it to the resources, which is a b. So 100 here, 40 here, and what? 5 here. Okay. So what's the first thing to do? What is the first thing to do, guys? You have something and you are told to find the identity matrix for that. Because by finding the identity matrix, the matrix A here will change to matrix I, and the matrix B here will also change to matrix K. Now, what do you think the first step is? Oh, please, okay.
Well, we have to augment.
Augment. So by augmentation, we ignore the X, we attach the B to the A. Raising it to 10, right? So 20, 15, 10, 1, 2, 1, 0, 0, 1. Then you augment the line. So 400, 40, and 5. Now with this one, they've already the rule 3 is fine because the matrix, the identity matrix we are looking for is like this. This one. So you are seeing that this one is correct in the question. So we have 0 here, we have 0 here, we have 1. So you will not touch the rule 3. So we are going to deal with the rule 2 and rule 1. All right. So the first step I will go for is that let's interchange rule 2 and rule 1. So by interchanging rule 2 and rule 1, so interchange rule what? Rule 1 and what? Rule 2. So how do we interchange? Just change their positions. So we have, so the rule 3 nothing will change there. Rule 5. Now let's change the rule 3 and 1. So rule 2 will be rule 1 in our question and our answer. So 20 will come to rule 2, 15 will come to rule 2, 10 will come to rule 2. Then the 400 here will come to rule 2, which is to replace the 40 here. Then the rule 2 will move up to rule 1. So 1, 2, 1. But this is simple. All right. So we are moving on. So now that we are done interchanging it, the second step I'll go for is what? Negative 20 I'll multiply negative 20 by row 1 and add it to what? Row 2. All right, so this is the equation or the formula I will use. So, and we are doing this on what? We are doing this on row 2. We are doing this on row 2. This will be on row 2. So row 1 won't change. So this is row 1. 1, 2, 1. 440 will be here. Then we have 0, 0, 0, 1, 5. All right. So let's do the calculation. So negative 20 times row 1. What is row 1 here? It's positive 1. It is positive 1 plus row 2. What is row 2 here? Row 2 is 20. The first element on the second row is 20. So plus 20. Now when you add this one is negative 20 plus positive plus 20 technology. So this one you get at 0. Okay, so let's do that for the second element on the second row. So with the second element on the second row, we are saying negative 20 multiplying row 1. What is row 1 on the second element? It is 2. Multiplying 2 plus what? The 15. The 15 is here. Right? 15 is here.
35.
So we are getting what? Minus 40. Then what? 15. And that should give us negative what? 25. Yeah. Okay. So the 10th one, so negative 20 times 1 plus what? Positive 10. We are getting negative 10. Then we have minus 20 times row 1 here is 40 plus row 2. What is there? 400. Negative 20 times 40 will give us
800. Negative 20 times 40 will give us negative 800.
Negative 800. Good. So if negative 800, then we have positive 400. What will be the answer?
Negative 400.
Negative 400. All right. Okay. Now that we are done, let's perform another operation on the same row 2. Because I'm interested in row 2. So with the third step, I will go for what? So let me give you a clue. Let me give you a clue here. You see that you are having a big number, negative 125. If it is positive and you want it to be what? Positive 1. If the number, the 25 here was to be what? Positive. You just multiply the 25 here by 1 over the same 25. But this one is negative. Because we need 1 here, because the identity matrix, we need 1 in the middle here. So go for what? 1 over negative 25. Multiplying row 2. 1 over negative 25. Multiplying row 2. So we are performing this operation on row 2. Now if you take the calculator, so row 1, nothing will change. Row 3, nothing will change. So we are dealing with row 2. 40. Then 0, 0, 1. When you take 0, you multiply by 1 over negative 25, you are getting 0. When you take 1 over negative 25. Multiplying negative 25, you are getting positive 1. So that's the clue I've given to you. If you have a number and you want it to be what? A single positive 1 or something, just multiply it by 1 over that number. So this one, you multiply negative 10 by the 1 over negative 25, you are getting positive 2 over 5. Okay. And when you multiply negative 1 over 20, negative 1 over 25 by negative 400, you are getting what? Positive 16. All right. So any questions so far? Can I move on? Can I move on?
Yes, please.
Yeah. Okay. So we are going to add step 4. And the step 4 I would say that we want this negative 25 to be 2 over 5 to be what? 0. So that one to just take negative of 8, multiply with what? Root 3. You add it to what? Root 2. This one is addition, not multiplication. Remember, you cannot multiply 2 rows. All right. So by doing this, we are doing it on root 2. So root 1 and root 3, nothing changes. So the 1, 2, 1 stands. The 45, 0, 0, 1. So first of all, you take negative 25 and negative 2 over 5. You multiply it to row 3. Row 3, what is there? 0. 0 is here. Plus row 2. Row 2, what is there? Positive 1. Is it positive 1? No, row 2 is 0 still. Okay, sorry. Row 2 is 0 here. Okay, so you are getting 0 here. Then you count the second element, which is 1. Because the row 2 is 1 here. Row 3 is 0. So you are getting 1 here. And you multiply negative 2 over 5 by root 3. Root 3, the element here is 1 plus the 2 over 5 here. What will be the answer?
0.
0. Good. Good. Then I said every operation you perform, you must perform it to what? You extend it to the matrix you attach with the normal matrix. So you come here to, so negative 2 over 5 minus multiplying root 3. Root 3, what is there? 5. 5. You add it to what? Root 2. Root 2 is 16. What are we having? What are you getting?
14.
14. Good. Okay, so you see that we've gotten row 2 and row 3. So now we have to deal with what? Row 1 alone. We have to deal with row 1 alone. Now, by dealing with row 1, we want the 2 here to be 0, 1 here to be 0. So I would say that there's step 5. Let's multiply negative 1 by root 3. Negative 1 by root 3 plus what? Row 1 itself. So we don't have space here, so I'm just going to write the answers. I'm not going to work it for you. So we are going to work this on row 1. So nothing will change here, nothing will change, nothing will change, nothing will change, nothing will change, nothing will change. The same thing here. So we are dealing with row 1 alone. So 5, 5, 14. Then we deal with the top. Okay. So negative 1 times row 3 plus row 1. We are going to use this. When you punch it, we are getting 1 here. Negative 1 times row 3 plus row 1. When you punch it, we are getting what? 2 here. Negative 1 times row 3 plus row 1 here. You are getting 0 here. Then here, to change from 40 to what? 30. I don't have space to write the solution, so you can cross-check it yourself to see if there's a mistake somewhere. You got it. Now we move on to the last step, which is step 6. Now we are still on row what? Row 1. So we've gotten everything except these two. We want these two to what? Transform to 0. How are you going to perform that? And I'm saying we should multiply negative 2 by row 2 plus what? Row 1. And we are doing it on row 1. So nothing will change on row 2 and row 3. So 0, 1, 0, 0, 0, 1. Then we have what? 14, 5. So when you punch it, you follow the formula I've given here. You get here to be 1, here to be 0, and here to be 0. And here you get 7. Okay, so you can cross-check. Okay, I said 35 by, sorry. I said 35 by mistakenly wrote 30. Thank you for correcting me. So here will be 35. So here will be 7. So let's check the 7. So the 7, we are saying row 2 times row 1. What is row 2 times row 2? So row 2, we are dealing with this, so 14 plus row 1. What is the 35? Now 2 times 14 will give us 28 minus 28 plus 35. Then we are getting what? Positive 7. That's why we got 7 here. All right. So you see, we've gotten the identity matrix. You've gotten the identity matrix that we wanted. And the B here, the 445 has changed to what? 745. So the 5 was the only element in that matrix that didn't change. So let's name it this key. Now, after this, just bring in what you ignored, the X matrix. So it should be 1, 0, 0, 0, 1, 0, 0, 0, 1, multiplying your x1, s2, s3. Then you equate it to what? The k, that is the 7, 14, and what? 5. And we know that the special property of identity matrix is that when you multiply any identity matrix I by any other matrix X, you are getting what? The same as the X. So your answer will be X here. So X1, X2, S3. Equating what? The 7, 14, and what? 5. So that will be our answer. So the value for x1 is 7, the value for x2 is 14, the value for s3 is 5. Any questions so far? Any questions so far? Any questions so far?
No question.
Will you all understand what we've done today? Do you understand what we've done today?
Yes.
Alright. Let me pause it. So we've ended here. Next time we meet, you start with what finding inverse of a matrix, and this one is quite similar, but I just add some little things. Right. So don't forget to like, subscribe, and share our YouTube channel. Thank you. Have a good night. Bye bye.